We're going to start our journey with cellular automata by looking at one-dimensional systems first. This webpage, Wolfram Mad World, is one of the best resources, in my opinion, out there to get started with the concept of cellular automata. What are known as elementary cellular automaton refer to the idea of visualizing as a generational history, where the rows represent a population and different rows from top to bottom represent the history of that population moving forward. We're going to apply a series of rules whose configuration encode what the state of a tile is going to be from one generation to the next one. These rules can change, but it always stays within binary numbers, where 0 is a white tile and 1 is a black tile. In this project, we're going to use rule number 30, which is this one that is demonstrated right here, in order to generate this fractal. Let's take a look at the algorithm. So here we start with a population of tiles. These tiles only exist in one row. They have neighbors to the left and they have neighbors to the right, but there is nothing above or nothing below. So we are going to start by making one of these tiles manually black. That is to say that its state is going to change from 0 to 1. And then we're going to take our guide for the rule number 30, and we're going to start from the second tile on the left. Notice that this tile over here doesn't have neighbors to its left. And this last tile over here doesn't have neighbors to the right. So we can't really apply the rules of counting 3 tiles if there is one missing over here and over here. So we just don't count those tiles. We're going to start with the second one. So we start in the second tile. Here we find in the guide of the rule 30 the configuration that corresponds to these 3 tiles, which in this case is this one right here. That means that this tile over here remains in a state 0. We move to the tile to the right, these 3 neighbors right here. Well, these 3 tiles seem to match this item in the rule 30. So the next state is going to be a 1. We move to the right. These 3 tiles correspond to the third item from right to left in the rule 30. So it remains in a state 1. The next one is going to be these 3 tiles, which corresponds to this item in the rules. So the next state is also going to be a 1. We move to the next ones, and we finish an iteration applying the same logic throughout the entire system, stopping at the last tile. If we repeat this, we're going to end up with this beautiful visualization, which is a pattern that surprisingly enough is also found in nature. If you search for rule 30 snail, you're going to see images of this beautiful shell whose color pattern is matching the rule 30. Let's implement this algorithm using Python.